Welcome to 10th class mathematics classes. Let's continue coordinate geometry part 2. Okay. So we have learned the similarity of triangles and then basic proportionality theorem, criteria for the similarity of triangles, which we have learned, that angle rule, side rule, and side rule, side. Okay, SSS rule, right? Now we will continue learning areas of similar triangles, then Pythagoras theorem, Baudhayana theorem, and then different forms of theoretical statements. Okay, which is not exactly related to coordinate geometry, but it's very important for the math. So let's learn all these things in this video. Okay, areas of similar triangles. Okay, now so far we have learned that all the ratios with respect to a similar triangle are same, whether it is side, okay, ratio of corresponding sides, ratio of corresponding medians, ratio of corresponding altitudes, ratio of corresponding angular bisectors, all are same ratio, right? So do you think the area is also in the same ratio as the sides? Okay, let's do a small experiment to first understand whether it will be same or not. Okay, so if you see this given graph here, okay, the area A is, you can see the shape of it. It is in the uh, shape of reversal, right? Okay, and which is the similar shape of this one? This has 1 2 3. Okay, and if you see here, C, okay, this shape is exactly same as A, correct? Let me try it. I counter. So A is here and C is here, which is exactly similar figure. But do you think their areas are same? Okay, definitely not, right? Here you have 3 units, okay, 3 square units. Here you have 1 2 3 4 5 6 7 8 9 10 11 12 square units. It's 4 times actually, right? And just for curiosity, we'll check what is the side of this shape here. 1 2 units on the topmost horizontal, right? Here it is 1 2 3 4. Okay. So anything striking? The ratio of side, okay, corresponding side, if you take, it is 2 times, correct? But the areas are not in the same, right? Okay, this is 3, this is 4 times. 3 times 4, which is 12. So is it like 2 square times? Okay, because the ratio of sides is 2 times and areas are in 2 square times. Okay, let's check that. Okay, the ratio of areas of two similar triangles is equal to the ratio of squares of their corresponding sides. Okay, this is the theorem. Let's prove it. Okay, ABC is similar to QPQR. Okay, we can see here. And we are drawing a altitude, that is perpendicular line AM and PN here. So this is the height of this triangle. Okay. Now area of ABC by area of PQ are equal to, okay, AB square by PQ square or BC square by QR square or CA by RP square. This is what we are required to prove. Okay, this is required to prove, right? Okay, so this is what we need to prove it. Okay, now let's see. Okay, we are drawing the perpendicular lines, and then area of ABC by area of PQR is nothing but half into base into height, half into BC into AM, okay, and half into QR into PN, right? Which is equal to half gets cancelled, BC by QR and AM by PN. And AM by PN are the perpendicular lines, so which will be in the same ratio as BC by QR, correct? AM by PN is nothing but equal to BC by QR, right? So which means you will get area of ABC by area of PQR equal to, okay, BC by QR square Or you can take it same triangle, you draw a perpendicular line onto AC, you will get AC by PR square or AB by PQ square. Okay. So all the three are possible basically. Okay. Which we are trying to tell is the areas of two similar triangles is equal to the square of their corresponding sides ratio. Okay. So this is what we have proved. Now, prove that if areas of two similar triangles are equal, then they are congruent. Okay. Now, next question is if area is same, then they are congruent. Okay. So, area of ABC by area of PQ are equal to AB square by PQ square. Okay. Right. This we know. One of this. Now, we are telling this is equal to 1. Right. Areas are in the ratio of 1, which means AB square by PQ square equal to 1, and also this 2 also equal to 1, which means AB square equal to PQ square or AB equal to PQ and BC equal to QR, AC equal to PR, which means it is a congruent, those are congruent triangles basically, right? Let's see example now, example problems. Triangle ABC is similar to triangle DEF and their areas are respectively 64 centimeter square and 121 centimeter square. If EF equal to 15.4, find the BC. Okay. So areas of two similar triangles in the ratio of the square of their corresponding sides ratio. So if you use this formula, 64 by 121 equal to BC by 15.4. Okay. So from this we can easily derive BC equal to 11.2 centimeters. Okay. Similarly, next example. In a trapezium ABCD, okay, with AB is parallel to DC, AB is parallel to DC, diagonals intersect each other at a point O. If AB equal to 2 CD, AB is twice CD. Find the ratios of areas of triangles AOB and COD. AOB and COD. Okay. Now, it's very easy. We know that AOB and COD form similar triangles. Why? We know that already we have done this before. The angle here is equal to angle C here. The angle D here is equal to angle B, and these two angles are same. Okay. So which means these two are similar triangles. Correct. So which once we know that they are similar triangles, their areas are in the ratio of squares of their sides, which means AB square by DC square is nothing but AB is twice that of DC, so it will be 4 times. Right. Okay. So let's go into the exercise now, 8.3. Okay. DEF are midpoints of BC, CA, AB of ABC. Okay. These are the DEF are the midpoints of triangle ABC side. Find the ratios of DEF and ABC. Okay. DEF and ABC. That is big triangle. Okay. Now E and F are midpoints of AB and AC. We know this. So which means EF is parallel to BC and EF equal to BC by 2. Correct? Okay. So in triangle ABC and AEF, angle triangle ABC and AEF. Okay. Since this is a parallel line, they are similar triangles, right? We already know that they are similar triangles. So by which implies area of AEF by area of ABC equal to EF by BC whole square. Correct? You can take any corresponding side. Okay, I'm just taking EF by BC whole square. Okay. Now we know that EF is half of BC. Why? Because this is joining midpoint. E and F are midpoints of triangle, right? So this will be half of BC. So it is 1 by 4. Okay. So you can actually just to extend it, you can prove that not only E um, AEF, not only AEF, we can also prove that BED also 1/4 and DCF or DFC also 1/4. So these three uh, areas are 1/4, 1/4 and 1/4. which means what is the remaining area? This has to be 1/4, correct? 1 minus 3 by 4, which is 1/4, right? So area of DEF equal to 1/4 of area of ABC. Okay, and just for your information, all four are a similar triangle. Okay, you can prove very easily all four are similar triangles. Okay, next. In triangle ABC, XY is parallel to AC and XY divides the triangle into two parts of equal area. Find AX by XB. So XY is parallel to AC and XY is dividing this triangle into two equal areas. That is, area of BXY is equal to area of AXYC. Okay, now area of BXY equal to area of XYCA, which is equal to area of half of ABC. Correct? Half of area of ABC. Given that ABC, in ABC triangle, XY is parallel to AC. Okay, we know that ABC is similar triangle. Triangle ABC is similar to triangle XBY. Okay, right? XBY. Okay, it will be similar. So area of ABC by area of XBY equal to AB by BX whole square, or AB square by BX square, which is equal to 2. Because why is this? AB and BX. Okay, AB and BX equal to 2 I wrote. Why? Because area of XBY is half of ABC. Correct? So it is 2. Now let's find out the uh, AB by BX, which is equal to square root of 2. Okay, squaring on both sides. Now how do I get AX now? AX is nothing but AB minus BX. Correct? AB minus BX. So I will subtract minus 1 from both sides. Then I will get AB by BX minus 1 equal to square root of 2 minus 1, which means AX by XB equal to square root of 2 minus 1. Okay. Next. Prove that ratios of areas of two similar triangles is equal to the square of the ratios of their corresponding medians. Okay. This is just extension of same theorem. Before we know that areas of similar triangles, ratios of areas of similar triangles is equal to squares of ratios of their corresponding sides. Correct? So we know that medians also is in the same ratio as sides. Correct? Medians also in the same ratio as sides in a similar triangle, which means the ratios of areas of two similar triangles is equal to square of medians also possible. Correct? So let's see. Triangle ABC is similar to triangle FEG. Okay, which means this angle CAB equal to angle GFE, and AC by FG. Okay, corresponding sides basically I'm taking. AC by FG equal to AB by FE. AB by FE, which is equal to AB is nothing but twice AD, 2 AD by 2 FH, which means AD by FH also. Correct? I'm trying to prove both are similar triangles. So the similarity rule is satisfied with SAS rule. Side, that is this AC, AD, and angle, which is common, right? So these are same, so they are similar triangles. So their areas are in the ratio of CD square by GH square. Correct? Median divides two triangles into two equal areas. Okay. Okay. Since if I add, I mean 2 on the numerator and denominator, it will become twice area of triangle ACD, twice area of triangle FGH, okay, which is nothing but area of ABC by area of FEG. Okay, so this is proof. Next, triangle ABC is similar to triangle DEF. BC equal to 3, EF equal to 4 centimeters, and area of ABC equal to 54 centimeters. Determine the area of DF. This is a straightforward thing. Just substitute the values, you will get it. Okay. ABC is a triangle and PQ is a straight line meeting AB uh, in P and AC in Q. Okay, you can see the picture. If AP equal to 1, BP equal to 3, AQ equal to 1.5, CQ equal to 4.5, prove that triangle APQ equal to 1/16th of ABC. Okay. So first thing is what we need is what is the ratio of their corresponding sides. Once you know that, then it is very simple, right? So given that AP equal to 1, BP equal to 3, which means AP is 1/4 of AP is 1/4 of AB, correct? Once you know that AP is 1/4 of AB, areas of similar triangles equal to AP square by AB square, which is equal to 1/16, right? So that is what we did here, same thing. Okay, next. The area of two similar triangles, sorry, the areas of two similar triangles are 81 centimeter square and 49 centimeter square respectively. If the altitude of bigger triangle is 4.5 centimeters, find the corresponding altitude of the smaller. Okay. So ratio of two similar triangles equal to ratios of squares of corresponding altitude. How? Uh, we learned that ratios of two similar triangles equal to ratios of squares of corresponding sides. Okay. Also, we know that corresponding altitude ratios also same as corresponding sides. Correct? So, which means we can say ratio of squares of corresponding altitude also. Okay. So, now once you know that, you just substitute the values, you will get the altitude of the smaller triangle, which is 2.34. Okay. Next, let's learn the Pythagoras theorem now. Okay. So, we have used Pythagoras theorem so many times, and Pythagoras is the famous mathematician who has proposed few theorems on the right angle triangles. Okay. So, let's learn them. Okay. If a perpendicular is drawn from vertex of a right angle right triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle and to each other. Okay. Don't get confused. What is trying to tell is you have a right angle triangle. Okay. Right angled at B. Okay. Right angled at B. If you draw a perpendicular line from B onto AC, that is BD. Okay. Now ADB, okay, BDC and ABC all are similar triangles is telling. Okay. So, hope now you realize that this is not the Pythagoras theorem you heard, right? So, this is another one, okay? Another one which Pythagoras has proposed that on the similar triangles, okay? So, in a right angle triangle, if you draw a perpendicular from the right angle, then this divides the triangle into two parts, and these two parts are similar, and they are similar to the main triangle. That's what the summary is, okay? So in ADB and ABC, if you take first ADB and the main triangle, that is ABC. Okay. Angle A is common and BDA equal to ABC. BDA equal to ABC because both are 90 degrees, right angle triangle. Okay. Now, which means from angle rule, there are, you can call them similar triangles, ADB and ABC. You can already call them similar triangles. So this is our first one. Now, similarly, I can prove BDC is also similar to ABC. Correct? Now, use the transitive property, and third, the ADB, triangle ADB and triangle BDC also similar. Okay? So, this is very simple. The only thing is, we should remember this and apply it at right time. Okay? That is important. Almost all the theorems are very easy. But the most important thing is you have to remember, depending on the problem, which theorem to apply at the right time. Okay. So this is what is about the Pythagoras theorem of similar triangles. Now, yeah, this is Baudhayana theorem. Okay. So this is the actual Pythagoras theorem which we always hear: a square plus b square equal to c square, right? So why it's called Baudhayana theorem? Now, after so many years, they found that actual Pythagoras theorem, that is a square plus b square equal to c square, is actually there in Indian ancient scripts. Okay, so they renamed it as Baudhayana theorem. Okay, so the theorem says, of course, length of hypotenuse is equal to the sum of squares of square of length of hypotenuse, that is ac square. One of the proof of uh, Baudhayana theorem or Pythagoras theorem. So we normally tend to say always Pythagoras theorem. Get used to it because we don't know when who will ask it as a Baudhayana theorem. You should remember this is nothing but the old Pythagoras theorem which you learned. Okay. So ac square equal to ab square plus bc square. This we have to prove. Okay. So draw a perpendicular, same like before. So now we know that ADB and ABC are similar triangles. So AD by AB equal to AB by AC. Okay, AD by AB equal to AB by AC. Okay, which means AB square equal to AD into AC. Okay, now again, second triangle you take BDC and ABC. Similarly, you can get BC square equal to CD into AC. Okay, BC square equal to CD into AC. Now add these two, what you will get is AD into AC plus CD into AC equal to AB square plus BC square. AC is common, take the common AD plus CD, AC into AD plus CD. What is AD plus CD? AD plus CD. This is nothing but AC, correct? So it will become AC square equal to AB square plus BC square. So this is the uh, proof of Pythagoras theorem or the Baudhayana theorem. Okay. So this is one of the way. There are several people proved it in several ways. This is one of the way using similar triangles, which is also actually proposed by Pythagoras by himself. Okay, that is how he proved it. The above theorem was earlier given by an ancient Indian mathematician Baudhayana. Okay, his name is Baudhayana, about 800 BC in the following form. Okay, the diagonal of a rectangle produces by itself. The diagonal of a rectangle produces by itself the same area as produced by its both sides, length and breadth. Okay, this is the original one is in a Sanskrit sloka. Okay, so it's interesting to learn the history from where it has come. And just to remind you, look at the date here. This is about 800 BC. Okay, so you can imagine how much mathematics is there in our blood. Okay, so many years, and we know Pythagoras theorem around 800 BC. Since then, we are using it, right? So maths is in our blood. Yeah. Next, other theorem. In a triangle, if square of length of one side is equal to the sum of squares of lengths of other two sides, then angle opposite to the first side is the right angle. Okay, this is basically exactly reverse of Baudhayana theorem. Okay, if AC square equal to AB square plus BC square, then B is 90 degrees. That's what we are trying to prove now. Okay. So construct a right angle triangle PQR. Okay. Right angle at Q such that PQ equal to AB and QR equal to PC, which means we constructed a congruent triangle. Okay. Now, because PQR is a right angle triangle, okay, with these two sides. Okay. Now PR we don't know. Okay, we have to measure. So PR square equal to PQR, PQ square plus QR square, because this is the 90 degrees I constructed. So PR square is obviously equal to PQ square plus QR square. But PQ is nothing but AB, QR is nothing but BC. So AB square plus BC square equal to PR square, right? By construction. Okay, now it is given that AC square equal to AB square plus BC square. That means PR and AC are same basically, right? AC equal to PR. Okay. So now we know that PQR is congruent to ABC, correct? PRQ or PQR is congruent to ABC, triangle ABC, which means if this is angle 90, B is the angle, sorry, Q is angle 90, then B also should be angle 90. Okay, so that's how we prove the reverse of Baudhayana theorem. Okay. Let's see some examples. I think you could have done several examples by now on based on Pythagoras theorem. Let's do some more. A ladder 25 centimeters long reaches the window of a building 20 meters above the ground. Okay, determine the distance from the foot of the ladder to the building. Most important thing in geometry is to construct the uh, diagram correctly. Okay, now it's a ladder of 25 centimeters. So ladder is 25 centimeters. It reaches window of a building. Okay, if this AC is a building, then it reaches the window. Window is at A. Okay, so BA equal to 25 meters. Right? So this is my ladder. And what is AC? AC is the building, and at A there is a window. Okay. Now, distance from foot of the building to the ladder we need to find out. That is BC. And ladder, the building always makes 90 degrees with the horizontal line, right? With the ground. So this is 90 degrees. So it's a right angle triangle. Now just apply Pythagoras theorem. You will get answer as 15 meters. Okay. BC square equal to 25 square minus 20 square, which is 15. Okay. Now BL and say CM are medians of triangle ABC. Okay. BL and CM are medians of the triangle ABC. Right angled at A. At A it is right angled. Prove that 4 times BL square plus CM square equal to 5 times BC square. Okay. So again we will basically apply the Baudhayana theorem or Pythagorean theorem here. Okay. BL and CM are medians of ABC. Okay. And ABC is a right angle triangle. So BC square equal to AB square plus AC square. Okay. Similarly, triangle ABL. Okay. ABL. This is also right angle triangle. So BL square equal to AL square plus AB square. Okay. Now BL square equal to AL. I am writing it as AL. I am writing it as half of AC because it's a median, right? So half of AC square by 2. Okay, so BL square equal to AC square by 4 plus AB square. Now, yeah, you can rewrite it as 4 times BL square equal to AC square plus 4 times AB square. Similarly, in CMA also, we can derive using Pythagorean theorem. 4 CM square equal to 4 AC square plus AB square. Okay. Now, from this 1 and 2, we can derive the required one, which is 4 times BL square plus CM square equal to 5 times BC square. Okay. Next. If O is any point inside a rectangle ABCD, prove that OB square plus OD square equal to OA square plus OC square. Okay. Any point in rectangle you take, it basically forms a multiple 4 triangles, right? And OA square plus OB square, sorry, OB square plus OD square, opposite sides, okay, is equal to OA square plus OC square. Okay. So this is also easy to prove using Pythagoras theorem. You draw a parallel line. Okay. So that means this PQ also uh, bisects this into right angle triangles, each one into two right angle triangles. Okay. AOB and DOC. Okay. With that, we can just apply Pythagorean theorem here. You will get the required answer basically. Okay. Okay. In triangle OPB, if you see OPB, okay, OB square equal to BP square plus OP square, correct? BP square plus OP square. BP is nothing but half of AB. Okay. Remember that. Similarly, in OQD, we can get OQD. If you see OQD, okay, we can get similar equation. In OAP, here we can get one equation. Okay. So with this four, okay, we can derive that OB square plus OD square equal to OC square plus OA square. It is simple uh, addition basically. Once you derive this, okay, simple addition. Check carefully. It's very simple. Okay. Next. Okay, do this. Let's do this exercise. Okay, in triangle ABC, C is 90 degrees. Okay, CD is perpendicular to AB. You can see prove that BC square by AC square equal to BD by AD. Okay, so sorry. Okay, from the given data, Pythagorean theorem of similar triangle. All these triangles are similar triangles, correct? So once you know that, from ABC and ACD, which are similar triangles, AB by AC equal to AC by AD. Okay, AB by AC equal to AC by AD. Okay, similarly, in other two triangles, you can get BC square equal to AB into BD. Okay, so you divide these two, BC square by AC square equal to BD by AD, right? Okay. A ladder 15 meters long reaches a window which is 9 meters above the ground. Okay. The window is here at D. Okay. And this is building above the ground. Okay. 9 meters. Ladder is here. Okay. DC is the ladder which is 15 meters. Okay. Keeping its foot at the same point. Okay. I kept the ladder foot at C and moved this to other side. Okay. Of the street. Then it has reached 12 meters high on the other side of the street. Okay. That means AB is 12 meters. Okay. Ladder is same, right? Ladder length will not change, right? So that is still 15 meters. 15, 12, 15, 9. And the question is, what is the width of the street? Which is BE. Correct? BE is the width of the street. So you calculate CE and BC independently and then just add them. Okay. So that's what we did. Applied Pythagorean theorem and just started them. 21 meters is the answer. Okay. In the given figure, AD is perpendicular to BC. Prove that AB square plus CD square equal to, which is AB square plus CD square equal to BD square plus AC square. Okay. Two right angle triangles are there, which is ADB and ADC. Correct. Applying Pythagorean theorem in ADB, we'll get AD square equal to AB square minus BD square. Similarly, in the other triangle, you apply Pythagorean theorem, you get AD square equal to AC square minus CD square. You equate both of them and adjust, you will get required answer. Okay. Yeah. Next. Let's see some more examples. The hypotenuse of a right angle is 6 meters more than twice of the shortest side. Okay. More than twice of the shortest side. If the third side is 2 meters less than the hypotenuse, then find the sides of the triangle. Okay. So first thing is, which one you will call x? Okay. Let's call shortest side as x. Okay. Then hypotenuse will become 2x plus 6. 6 more than twice the shortest side, correct? So hypotenuse is 2x plus 6. Third side is, okay, 2 meters less than hypotenuse, right? That is 2x plus 6 minus 2, which is 2x plus 4. Now you have three sides. Apply Pythagoras theorem. 2x plus 6 whole square equal to x square plus 2x plus 4 whole square. You simplify, you will get x equal to 10 or minus 2. Length cannot be negative, so you will take x as 10. So the sides are 10, 26 and 24. Next. ABC is a right angle triangle, right angled at C. Okay, you can see that BC equal to A. This is A, B, P. Okay, let P is the length of perpendicular from C onto B, AB. Okay, now prove that PC equal to AB. This is one proof we have to do, required to prove. Then 1 by P square equal to 1 by A square plus 1 by B square. Okay, so let's see. First thing is CD is perpendicular to AB, so CD equal to and CD equal to P. Okay, area of triangle ABC equal to half into base into height, right? That is half into AB into CD, so which is half into CP. Okay, similarly, area of triangle also you can say half into BC into AC. Okay, this is base, this is height, so is equal to half into AB. If you equate both of them, you will get CP equal to AB. Correct. So this is our first proof. Second one is simple. You apply the Pythagorean theorem. Okay, C square equal to A square plus B square. C is nothing but AB by P. From this you can derive. So if you substitute that, you will get Okay, this is what you get. Okay, so 1 by p square equal to ab whole square. If I take it to other side, it will become a square plus b square by a square b square, which I can rewrite it as 1 by a square plus 1 by b square. Okay, so let's see the exercise now. Exercise 8.4. Okay, prove that sum of squares of the sides of a rhombus is equal to the sum of squares of its diagonals. Okay, so ABCD is a rhombus. Okay, and AC and BD are diagonals, which you will know that they bisect at 90 degrees, perpendicular bisection basically. So we have to prove that AB square plus BC square plus CD square plus DA square equal to AC square plus BD square. Okay, so look carefully. What are the things we need first? Okay, we need AC, we need BD. Okay, and if I take consider this right angle triangle. Okay, if I consider this right angle triangle, I get AE and BE, correct? AE and BE. Mm. Now, if I make it 4 times, what will happen? Simple. If I make 4 times, this is 2, 2, 4, right? Sum of them equal to 4 times of AB square, which is all sides are same, correct? So that is the simple thing. From visually we can tell this is very easy to prove. Okay. So rhombus diagonals divide it into 4 right angle triangles. Okay, applying Pythagoras theorem in all. Okay, doing a different way, but yeah, easy. Okay, AB square equal to AE square plus BC square, or which is nothing but AC square by 4 plus BD square by 4, because they are half. Similarly, other 4 right angle triangles, then add all of them. Basically, what you will get is AB square plus BC square plus CD square plus DA square equal to AC square plus BD square. Okay, this is what you get. Okay, next. ABC is the right angle uh, at B. Let D and E be any points on AB and BC respectively. Prove that AE square plus CD square equal to AC square plus DE square. Okay. D and E are any points. Okay. So just to prove that AE square. Okay. AE black one. AE square plus CD square. Okay. This one equal to AC square. Okay. AC square plus DE square. Okay. Two hypotenuse of the bigger triangle, and as well as the smaller right angle triangle also, D is hypotenuse, these two. Okay, so from there itself we can see it's very easy to prove actually. Okay, let's see. Applying Pythagoras theorem in triangle AEB, triangle AEB. Okay, AEB, this is another right angle triangle. Okay, so we get AE square equal to AB square plus BE square. In CDB, if you apply, okay, CDB, okay, this is another right angle triangle. In this, what you will get is CD square equal to BC square plus DB square. In DBE, okay, where is DBE? The smallest one, DBE. Okay, here DE square equal to BE square plus DB square. AC square equal to AB square plus BC square. That's the bigger one. Okay, now from this 4, we need AE and CD, right? So how do you take? Okay, AE square plus DE square. Okay, AE square plus AE square plus DE square equal to AB square plus BC square. Sorry, not AE. I took AC square plus DE square. So AC square plus DE square. Last 3 and 4 basically. Adding 3 and 4 I get AC square plus DE square equal to AB square plus BC square, B square plus DB square. Correct? Which is equal to AE. AC square, AB square plus BC square is what? CD square. Sorry. Uh, AB square plus BE square. Okay, these two. Okay, AE square plus AB square plus BE square is AE square. BC square plus DB square is CD square. Okay, if you substitute, this is what you get. Okay, next. prove that 3 times the square of any side and of an equilateral triangle is equal to 4 times the square of altitudes. Okay, 3 times A, if A is the side of a equilateral triangle, okay, equal to 4 times uh, altitude, that is AD here. Okay, let's see. Okay, it divides BC into equal parts. So ADB is a right angle triangle. AB square equal to AD square plus BD square. Correct? AB square equal to AD square plus BD square. Okay, which means BD equal to BC by 2 or A by 2. Okay, so if you substitute that value, what you will get? A square equal to AD square plus A by 2 whole square, which implies AD square equal to, that is altitude, right? Equal to 3A square by 4, which means 3 times A square equal to 4 times AD square. Correct? Next. PQR is a right angle triangle at P and M is a point on QR such that PM is perpendicular to QR. Show that PM square equal to QM into MR. I think we have done this in the exercises, similar one. So just follow this. It's very easy. Okay. You just figure out you will get three equilateral triangles, three similar triangles, right? So from the three similar triangles, you can easily uh, derive. Okay. Okay. Next. Instead of mentioning all this similarity, I just try to prove the similar triangles here. You can mention with Pythagoras theorem, right? Pythagoras theorem of similar triangles. You can mention these three are similar, and then just in next step you can easily prove it. Next, ABD is a triangle, right angle at A, and AC is perpendicular to BD. Show that those three. Okay, so this is the picture. Right picture is there, so it's easy. AC square equal to BC into CD. This is what you should get. So how do you get it? These three are the similar triangles. Okay. So AB by CB equal to BD by AB. Okay. Basically, you need AB square, right? One side. So you take two triangles which have AB. Okay. These two triangles have AB. Correct. So you take those two. Then write AB. How it can come twice? AB by CB. Okay. AB by CB equal to BD by AB. Okay. So since these are similar triangles, very easy, right? AB by CB, BD by AB. Okay. So AB square equal to BC into BD. That's the first one. Second one, you need to get AC square. So where is AC? You take those two triangles. AC is here in both of them. So you take those two, and then you can prove. Similarly, third, where is AD? AD is here, AD is here. So you take those two triangles as similar triangles, then you can prove it. Next. ABC is an isosceles triangle, right angle at C. Prove that AB square equal to 2AC square. Okay. So this is very easy. Okay. So AB square equal to AC square plus BC square. Since AC is BC, we just say that AB square equal to 2AC square. That's it. Next. O is any point in the interior of a triangle ABC. Okay, OD is perpendicular to BC, OE is perpendicular to AC, OF is perpendicular to AB. Okay, now you have to prove all those things. Okay, this is very easy. Just there are several right angle triangles formed. Okay, so you cut it like this. How many? You have 6 pairs of right angle triangles, right? So it's very easy to get whatever value you want. Okay, now these are the right angle triangles. You first write all 6 equations. Now you derive what you want actually from this. Okay. Just make sure that things are there. You are not, making any mistake in the writing of side. Okay. That's it. Next. It's very easy to prove from all these things. Next. A 24 meters long wire is attached to a vertical pole of height 18 meters and stake it has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut? Okay. So This is something like this actually. Okay, you have a 24 meter long wire attached here. Okay, with a vertical pole of 18 meters. So this is a vertical pole. AB is the vertical pole. There is a wire attached which is 24 meters. Initially, it is just here. Okay. Now I hold the other end of the wire and started walking until this wire is tight. Okay, not loose basically, which means I am forming a right angle triangle as shown in the picture here. Correct? Once you know that it's just a Pythagoras theorem, applying Pythagoras theorem. So BC square equal to 6 square root of 7. Okay, meter. Next. Two poles of height 6 meters and 11 meters stand on a plain ground. If the distance between the feet of the pole is 12 meters, then find the distance between their tops. Okay, this is also very easy. You have two poles, AB 6 meters, CD 11 meters. Okay, now there is a gap of 12 meters between them. Distance between them is 12 meters. Now it will form a first a rectangle here. Okay, till height of 6 and then a right angle triangle on top. Correct? And AP, if you call it P, AP is perpendicular to CP, same as CD is perpendicular to BD, right? And distance between their tops is AC basically. You need to find AC. So AC is nothing but 12 square plus 5 square, correct? That is 169. AC square is AC is 13 meters. Next. In an equilateral triangle ABC, D is a point on side BC such that BD equal to 1 by 3 BC. Prove that whatever 9AD square equal to 7 AB square. Okay, so figure, I think I the figure in the end. So this is the figure. Okay, I have a equilateral triangle ABC. Okay, and AE, D is just any point on BC. Okay, D is any point on BC. So which means, okay, first thing is it's a equilateral triangle. So AB equal to BC equal to CA or BD equal to one third of BC. BD equal to one third of BC, which is given, right? So AE is perpendicular to BC. This is drawn. Okay, we have to draw AE perpendicular to BC. Then it forms two right angle triangles. Now you derive whatever you want. BE equal to EC, so half BC. So in ADE, okay, the small right angle triangle here, AD square equal to AE square plus DE square. Okay, so now we need AD, right? Everywhere ADs we need. Okay, so AD square equal to AE square plus DE square. AE is square root of 3 by 2 BC, correct? So DE equal to BE minus BD. DE equal to BE minus BD. So if you substitute them, what you will get is AD square equal to 3/4 of BC square plus BC by 2 minus BC by 3 whole square. Alright. If you simplify further, what you will get is 36 AD square equal to 28 BC square. Okay. Or 9 AD square equal to 7 BC square. This is the, I mean, we are required to prove this thing. Okay. Next. The given figure, ABC is a triangle right angled at B. And if the points D and E trisect the BC, okay, trisect means BD is equal to DE equal to EC. Okay, 1x, 1x, 1x. Okay, BD is one third of BC total. Okay, and DC is two thirds of BC. BE is two thirds of BC. Okay, trisection means that's what it is. Understand that. It is again, it forms three right angle triangles which you can see. So you can easily derive from the three Pythagorean theorems applied. You can derive whatever you want basically, right? Very simple. Just go through the steps first, solve it yourself, then check it. Okay, you may end up solving better way than what I mentioned here. Okay, right, which is good. Next, ABC is an isosceles triangle, right angled at B. Similar triangles ACD and AB are constructed on sides of AC and AB. Find the ratio of areas of triangle ABE and ACD. Okay, so this is how it is. Okay, so you have right angle triangle ABC. On AB there is a equilateral triangle built, on AC another equilateral triangle built, right? So AB equal to A, so S is equal to, hmm, I think this S is wrong. Okay, AB equal to A. This implies BC is also A because it's an isosceles triangle. Okay, AC equal to square root of A square plus A square, which is A root 2. Okay, now this is the first step. ABE is similar to ACD. ABE is similar to ACD. Why? Because this is the equilateral triangle, this is the equilateral triangle. So angle, 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 you can say they are similar. Now area of ABE by area of ACD equal to AB square by AC square. Correct? AB square is nothing but A square, and AC square is nothing but A root 2 square. So which is half. Okay. So this is the answer. Next. Equilateral triangles are drawn on the three sides of right angle triangle. Show that area of triangle on the hypotenuse is equal to sum of areas of triangles on the other two. This is exactly a Pythagoras theorem, but instead of a square drawn on the Baudhayana theorem, basically, instead of squares drawn on the sides, triangles, equilateral triangles are drawn. But area is same always, right? Area is just half of that, half of height into base. So you will actually end up in the same thing. Okay. So if ABC are the sides, then A square plus B square equal to C square. Then multiply both sides with root 3 by 4. So you will get root 3 by 4 A square plus root 3 by 4 B square equal to root 3 by 4 C square. Okay. Root 3 by 4 A square is the area of equilateral triangle with side A. Correct. Similarly, other second one is with equilateral triangle area with B. This is equilateral triangle area with side C. So hence proved. Next. Prove that the area of equilateral triangle described on the side of square is half the area of equilateral triangle described on its diagonal. Okay. So AB the side of the square, diagonal is square root of A. Area of equilateral triangle with side A is root 3 by 4 A square. Area of equilateral triangle with side root 2A equal to root 3 by 4 into 2A square. Correct? Because root 2A square root of 2A whole square, which is 2A square. So it is nothing but twice the area of equilateral triangle on side A. Correct? Next. Yeah. Optional exercise. Just before going to the optional exercise, there is a small theory given here in the book actually, which is very important for your future proofs and everything. So just to learn it, very, very small theory. What is the negation of a statement? We know general statements. Okay. Um, Equilateral triangle has all three sides same. Okay, this is a statement, correct, which is true. So what is the negation of a statement is you have to add not in the statement. Okay, something like I am trying to say equilateral triangle uh, don't have all sides equal. Okay, so this is negation of the statement. Okay, ABC is the equilateral triangle if you denote it by P. Okay, if this statement is P, then P is nothing but triangle ABC is equilateral and its negation will be triangle ABC is not equilateral. Okay, understand? Uh, in other words, you have to add only negate the given statement. Okay, if I say let's say P given statement P is triangle ABC is equilateral and its negation, let's say if I write it like this, triangle ABC is isosceles triangle. Is it correct? No, this is not exactly negation of my previous statement. Okay, even though it is not equilateral triangle. I am indirectly telling it is not equilateral triangle, but it is not exactly the negation of my statement. So negation when you write, make sure that you are writing negation of exactly given statement. If triangle ABC is equilateral, that is my statement. The negation of the statement will be triangle ABC is not equilateral. That's it. Don't tell it is right angle, it is isosceles, it is scalene. You don't need to tell. Okay. Negation is normally denoted like this. Okay. Okay. And Yeah, this is what I was trying to tell actually. Don't get confused. And first, uh, write a simple statement and negate only the statement. Don't give any other derivative conclusions. Okay. All irrational numbers are real numbers. Okay, this is the statement P. Negation of P is all irrational numbers are not real numbers. That's it. Okay. How do you decide this negation is true or false? It's very easy. If the given statement is true, negation is false. If given statement is false, negation is true. Correct? Now, next we have another thing called converse statement. What is converse statement? A statement which is either true or false is called a simple statement. Correct? Right? This we know. A statement which is either true or false is called a simple statement. If we combine two simple statements, then we will get a compound statement. Okay, compound statement is nothing but summation of two simple statements. Connecting two simple statements with the use of words if and then, okay, it gives a compound statement which is called implication or conditional statement. Okay, example is if ABC is a equilateral triangle, then all sides are equal. If ABC is a equilateral triangle, then all sides are equal. Okay. Or other way, if all sides are same, it is a equilateral triangle. Then it is a equilateral triangle. This is called implication or conditional statement because the second statement depends on the first statement. Correct? Second statement. Okay. All sides are equal depends on the statement ABC is a equilateral triangle. Or other way, ABC is a equilateral triangle statement depends on the truth of all sides are equal or not. Correct? So that's why it is a conditional. How do you write the conditional? P implies Q, we call it, and we write it like this. P implies Q. Okay? P implies Q. We write it like this. This is the way we write. Okay? Now, okay. P implies Q in which in ABC, if AB equal to AC, AB equal to AC, that means two sides are equal, then C equal to B. Opposite angles are same. Okay, this is the isosceles triangle rule. So this is how we write it. Okay. Converse of it is Q is basically reverse of implication, right? Which is Q implies P in ABC. If angle C equal to angle B, then AB equal to AC. This is my converse. This is implication. Okay. So just know these things because you may use it in many places. Okay. And most of your mathematical theorems, all these things actually, we can try to use these symbols just to tell theorem is proved, then converse also proved, correct? So then other one, this is most important thing. It has given very small paragraph here, but I think this is every mathematics student has to learn it. Okay, this is one of the very easy methods of either proving or disproving a theorem or any equation or anything. Okay, prove by contradiction. What does it says? First, a statement is given. We have to prove something. Okay, then we just take the negation of the statement as true. Okay, if somebody says ABC is a equilateral triangle, first we will assume that ABC is not a equilateral triangle, and then we'll try to prove. If I am not able to prove my negation, that means it is a okay. That means it is a by contradiction, right? Right? If I prove my negation of statement is correct, then I am basically disproving the first statement. If I cannot prove uh, my negation statement, then the given statement is true, right? So this is what one of the very interesting ways of contradiction where we use this one. Okay, in this chapter where we used there is one place if I remember uh, reverse of proportional theorem we are proving. If uh, if a line is bisecting triangle both sides. If a parallel line is drawn to the third side, then it bisects the sides of the triangle in the same ratio, right? So we draw a line by saying that, okay, let's assume that BC is not parallel to, I mean, the line is not parallel to the third side. So we draw another line and then try to prove that, but contradiction happened, and uh, we have to tell that the parallel line is nothing but the same line given, right? So if you remember that example, you can go back into the video or the chapter. You can check, there are one or two places where we try to do use contradiction. Okay. Uh, Going forward, actually, in your higher classes, you use this as a actually a weapon. Okay, in mathematics. Most important thing, you can read more. Okay, let's do the optional exercise now. Okay, in the given figure, QT by PR, QT by PR equal to QR by QS. Okay, and angle 1 equal to angle 2. Prove that these two triangles are similar. Okay, so this is very easy. If two angles are same, which means we can take PR equal to QP, right? So it is given that QT by PR equal to QR by QS. So you replace QP with PR with QP. This is what you get, which means these two triangles have a Q as common angle. So by side angle side rule, these two are similar. Okay. Very easy. You can check where is PQS exactly. PQS is here. TRQ is TRQ is the bigger triangle. Okay. So check it carefully. Next. Ravi is 1.82 meters tall. He wants to find the height of a tree in his backyard. Okay. From the tree's base, he walked 12.2 meters. Okay. This is the tree base. From here, he walked 12.2 meters. Okay. Along with the tree's shadow to a position where the end of shadow exactly overlaps with. So AB is Ravi's shadow and AD is tree's shadow. That is how he walked exactly. Okay. He is now 6.1 meters from the end of the shadow. So this also given, and we know Ravi's height, and we know how much at what distance he is from the tree. So now, how tall is the tree? This is basically simple question of similar triangles, right? CB by ED equal to, you can say, AB by AD, correct? So you substitute the values, you will get it. Next. The diagonal AC of a parallelogram ABCD intersects DP at a point Q, where P is any point on side AB. Prove that CQ into PQ equal to QA into QD. Okay, so this is the diagram. You draw the diagram correctly. Okay, P is any point on AB. Okay, now DP intersect with AC at Q. Okay, now you know what are the CQ into PQ equal to AQ into DQ, right? That's what you need to prove. This very easily you can see that there are similar triangles formed actually. That is this APQ and CDQ, correct? So once you know that CQ by AQ equal to QD by QP, which means CQ into PQ equal to QD by AQ, right? Next. Triangle ABC and triangle AMP are two right angle triangles angled at B and M respectively. Okay. Prove that these two are similar and CA by PA equal to BC by MP. Okay. So if you see, ABC is here, AMP is here. Okay. In these two triangles, B is common angle. Where is B? Because it is 90 degrees. 90 degrees here, 90 degrees here. Okay. And then angle A is common. Okay. CAB and MAP both are same basically. So by angle rule, these are similar triangles, which is we proved now. Once you prove it, very easy. CA by PA, if you take, what you will get? Okay. CA by, not PA, sorry, this is BA. So, sorry, CA by PA, correct? CA by PA equal to, oh, I think this is AMP actually. Angle PMA. I think I choose a wrong CBA. It's not CBA, it is AMP actually. Okay. AMP and ABC are similar triangles. So now you get CA by PA equal to BC by MP, right? Okay. So this is a mistake here. Please note down the correction. This is triangle AMP. Next, an aeroplane leaves an airport and flies due north at a speed of, okay, let's say B is the airport. So it has flew to the north to A position at 1000 kilometers per hour. Okay. At the same time, another plane leaves the same airport and flies due to west, that is towards this direction at 1200 kilometers per hour. How far will the two planes be after 1.5 hours? So you are given speeds. Okay, so position A is basically 1.5 hour for the first plane, that is traveling at 1000 kilometers per hour. So 1.5 hour you will get 1500, correct? So AB is equal to 1500. The second one is 1200 into 1.5 hour, that is 1800. BC is 1800. Once you know that, this is very simple, correct? You just apply Pythagoras theorem, you get 300 square root of 61 kilometers. Okay, next. In a right angle triangle ABC, right angled at C, okay, P and Q are points on sides AC and BC respectively, which divide these on the 2:1 ratio. Okay, prove that these things. Okay, so we can clearly see right angles here, right angle triangles. So it's very easy to prove actually. And first thing is CP is equal to 2/3 of AC, which you note down because it is given that P is dividing it into 2:1 ratio. Correct? Similarly, Q. Okay, so QC equal to 2 by 3 BC. Now apply the Pythagoras theorem in ACQ. AQ square equal to QC square plus BC square. QC you can replace, right? Sorry, this is not 49, this is 4 by 9. Okay, please note down this is 4 by 9 BC square. Okay, so if I multiply with 9, I get 9 AQ square equal to 4 BC square plus 9 AC square. Okay, this is my first problem. Okay, second one is applying Pythagoras theorem in BCP. Okay, BCP in this right angle triangle. So BP square equal to BC square plus CP square. Okay, again I made a mistake here. It's not 49, it's 4 by 9. Please note down. This is not 49, this is 4 by 9. Okay, 4 by 9. So BP square equal to BC square plus 4 by 9 AC square. So again you multiply with 9, you get the second one. Similarly, uh, you add these two, basically you will get 9 AQ square plus BP square equal to 13 times AB square plus AC square. Okay, so BC square plus AC square is, we know that uh, nothing but AB square, right? From the right angle triangle ABC. Okay, sorry. Hope you understand this. So that's the basic introduction of the uh, similar triangles. So why I choose basically all these chapters of 10th classes, this is very much based to all your 11th and 12th classes mathematics actually. So at the time, I would just want to cover those also going forward for the competitive exams. Okay, like IIT, JEE, BITS, or any other competitive exam. So these are the basics. Okay, once you know this, when we solve those problems, I will not go into the theory part. Okay, we directly go learn the new tricks, new theorems. Okay, and there are much more in maths which you have to learn in 11th and 12th. So these basics we will not go through that at that time. Okay, so hope you these videos will help you for your basics of mathematics. Okay, and you will come up strong in maths actually. That's what I wish. Thank you.